Alright, so in this example, we need to find what's the pH of a buffered solution. You are mixing 1 liter of 0.02 molar benzoic acid and 3 liter of 0.06 sodium benzoate, and Ka value is given. Now we need to write the equation first. So we represent as HBz is benzoic acid, and we write Bz minus 1 is benzoate ion. And when we write the equation, we can say benzoic acid HBz, which is in aqueous, and H2O liquid, and when they are in equilibrium, H3O plus aqueous, and benzoate ion aqueous. So that's the equation we write first. Now we need to find concentrations of benzoic acid and benzoate ion. That's the first thing we need to find. Now we know that benzoic acid concentration, we have 0.02 molar and 1 liter. So we can find moles of benzoic acid, right? So we can see 0.02 molar and 1 liter. You can find moles of benzoic acid. But when you add, what's the total? We have 1 liter and 3 liter. Total 4 liter. So when you find out concentration of benzoic acid, you get 0.005 molar. That's the benzoic acid concentration. Now we need to find out benzoate ion concentration. Okay, so benzoate ion concentration follow the same steps. We are making total liter 1 liter plus 3 liter, so that's 4 liter, and we need to find out the moles of benzoate ion. So let's see, Bz minus 1, it's 0.06 molar, 3 liter divided by 1 and 3 liter, so total is 4 liter, and you get 0.045 molar concentration. Okay, so once we find concentration of these species, we apply ice chart to find equilibrium concentration. So we know that HBZ aqueous plus H2O liquid, H3O plus aqueous, Bz minus 1 aqueous, and we are going to draw ice chart. Initial SBZ concentration, what we calculated, 0.005 molar, and Bz minus is 0.045 molar. The change, negative X, and here positive X. At equilibrium, you get 0.005 minus X plus X and 0.045 plus X at equilibrium. Now, we need to write Ka expression. Ka expression is H3O plus concentration, benzoate ion concentration divided by benzoic acid concentration. Now we need to plug in the equilibrium concentration. So X times 0.045 plus X, okay, and 0.005 minus X, okay. Now we assume that this one is negligible. So for this one we consider only 0.045, and for this one we assume 0.005 because this change is very negligible. So Ka is given, which is 6.3 times 10 raised to minus 5 equals 0.045x divided by 0.005, and when we solve for x value you get 7.0 times 10 raised to minus 6 molar. That's the concentration of H3O plus. Now, can we calculate pH? Yes, pH equals minus log H3O plus, ion concentration, right? So, this is the value of H3O plus, concentration of H3O plus at equilibrium. So, now let's go to next slide. And we can say pH equals minus log H3O plus ion concentration. So minus log 7.0 times 10 to minus 6. And when you calculate you get 5.15 pH. So that way you can calculate pH of this acid.